What happens when an entire mountain range loses its ice? Imagine glaciers as nature's time-lapse, unraveling secrets frozen for millennia. The Alps, a lifeline for 40% of Europe's water, are now destabilizing mountainsides and threatening ecosystems shaped over thousands of years. These changes aren't just environmental. They carry a human cost, with communities facing landslides and water shortages. In this documentary, we've captured 4 years of rapid transformation in Switzerland's iconic peaks. Through time-lapse footage and historical comparisons, we expose changes that should span centuries but are unfolding in decades. The evidence is clear, and its implications demand your attention. The speed of melting compared to history. Glacier retreat isn't new. Ice sheets have expanded and contracted over millennia in natural cycles. But today's changes are happening at a pace that defies anything seen in recorded history. Since 1850, the Alps have lost 60% of their glacier volume, with half of that loss occurring in just the last 40 years. What was once a slow, natural process has become a rapid, almost torrential transformation. The Aletsch Glacier, Europe's largest, illustrates this dramatic shift. Between 2010 and 2020, it retreated 267 meters, more than 3 times faster than its average retreat rate during the 20th century. Nearby, the Morteratsch Glacier tells a similar story, now losing 30 to 40 meters annually compared to just 3 meters per year before 2000. These accelerating losses are not isolated. They reflect a broader trend across the Alps. Ice core studies provide a stark explanation. Annual layers in the ice reveal that current temperatures in the Alps now exceed any period in the past 12,000 years. Summer temperatures alone have risen 2 degrees Celsius since 1900, double the global average. This warming directly accelerates melting, as every degree increase reduces a glacier's mass balance by approximately 10%. The result is a feedback loop that compounds the problem, with each year bringing faster and more dramatic changes. For those who visit these glaciers, the evidence is impossible to ignore. At the Rhone Glacier, hikers and researchers have uncovered the remains of climbers who perished decades ago, now revealed as the ice retreats. Trails marked on 1980s hiking maps lead to barren rock instead of ice. In eastern Switzerland, the Pisor Glacier shrank so drastically that it lost its official status as a glacier in 2019, prompting a symbolic funeral to mark its disappearance. The physics behind this rapid decline further underscores the urgency. The albedo effect, which measures the reflectivity of ice versus darker exposed rock, plays a critical role. Fresh snow reflects up to 90% of sunlight, while bare rock absorbs up to 80%. As glaciers shrink, they expose more heat-absorbing terrain, creating a vicious cycle of warming and melting. Satellite data confirms this effect has increased local warming rates by 50% in some alpine valleys, amplifying the already dire situation. Time-lapse footage from observatories like the Jungfraujoch captures the speed of these changes. What once took decades to notice now unfolds visibly within months. At this rate, the Great Aletsch Glacier could fragment into 3 smaller remnants by 2040. Computer models predict that most major alpine glaciers could vanish entirely by 2100 under current emission scenarios, with smaller glaciers disappearing within the next 15 years. The consequences of this rapid transformation are already being felt. Mountain villages that rely on glacial water for agriculture and hydroelectric power face dwindling resources. In Grindelwald, the Upper Grindelwald Glacier's retreat of 50 meters annually has disrupted river flows, forcing farmers to install new irrigation systems to adapt. These communities are grappling with changes they thought would come generations later, now unfolding in real time. One hiker described the experience of standing where a glacier once loomed, now replaced by a desolate expanse of rock. "It's like walking through a memory that's fading," they said. This first-hand perspective brings the science into sharp focus. The glaciers are not just melting, they're disappearing before our eyes. Visible evidence of disappearing glaciers. Satellite images reveal changes in the Swiss Alps with a precision akin to a doctor's MRI, offering insights that ground-level observations alone cannot match. Comparing photos from 2003 to today, the retreat of the Trift Glacier is striking. Where solid ice once stood, a new lake has formed, one that didn't exist on maps 20 years ago. Similarly, the lower Grindelwald Glacier has lost 1.5 kilometers of length since the 1990s. Areas once blanketed in white now expose dark bedrock that hasn't seen sunlight for centuries. These transformations are measured through meticulous studies. Glaciologists use mass balance techniques, drilling poles into glaciers to track seasonal melt rates. On the Bassadino Glacier in southern Switzerland, poles that once stood firmly in thick ice now wobble as the ice beneath them vanishes. Since 2010, most monitored Swiss glaciers have lost an average of 2 to 3 meters of ice thickness annually, with some shedding up to 10 meters in particularly hot years. The retreating ice uncovers landscapes frozen in time. Near the Rhone Glacier, researchers have found tree stumps preserved under ice for 4,000 years, now exposed to open air. Alongside these ancient remnants, rusted climbing gear and World War-era artifacts emerge from retreating ice fronts. The newly revealed terrain often appears raw and unstable, covered in fine glacial flour, a powdery sediment created by grinding ice that now blows into valleys during dry spells. Glacial lakes are among the most visible signs of change. Since 1850, at least 1,200 new lakes have formed in the Swiss Alps, with over 180 appearing since 2006. Some, like Lake Marjolin below the Great Aletsch Glacier, have quadrupled in size since the 1990s. Others form suddenly when ice dams collapse. In 2018, a glacial lake burst in Val Ferret, washing away part of a road in a sudden flood. These lakes also pose risks, as meltwater undermines glacier stability and can trigger catastrophic outburst floods. The changes disrupt water systems that once relied on predictable glacial melt. Hydrologists note that rivers like the Rhone and Rhine, which used to benefit from steady summer flows, now experience more extreme patterns. Sudden floods from lake outbursts are followed by late-season droughts. The Mossa River below the Aletsch Glacier now peaks nearly 6 weeks earlier in summer compared to the 1980s, affecting everything from hydroelectric plants to drinking water supplies. Marker poles installed by researchers provide stark visual evidence of these losses. On the Clarendonfen Glacier, poles from the 1980s now stand dozens of meters above the ice surface, highlighting the dramatic thinning. Some poles have been extended with metal rods as the ice beneath them disappears year after year. At the Korvatsch Glacier, a measurement station that once rested on solid ice now hangs precariously over a growing crevasse, soon to collapse into the void it was meant to monitor. The scale of loss becomes even clearer when looking at glacier volume. While surface area changes are visible, the thinning of ice tells a more dramatic story. The Aletsch Glacier has lost over 100 meters of thickness in its lower sections since 1870. The Gorner Glacier near Zermatt has shed approximately 60% of its total ice volume since detailed measurements began. Even high-altitude glaciers aren't spared. Plain Mort Glacier in the Bernese Oberland has lost 25% of its thickness in just the past 30 years. These transformations also affect local infrastructure. Mountain huts built near glaciers a century ago now sit hundreds of meters from shrinking ice fronts. Hiking trails once marked as glacier crossings on maps now traverse barren rock fields. In 2020, workers had to relocate a Swiss weather station that was sliding into a crevasse caused by uneven melting. Communities that have long relied on stable glacial conditions are forced to adapt to these rapid changes. For residents, the evidence is impossible to ignore. Alpine guides in Zermatt report climbing routes shifting yearly as icefalls recede and rock faces destabilize. Farmers in the Lochen Valley noticed streams running dry earlier each summer. At ski resorts like Andermatt, workers now spend August covering glacier ski slopes with reflective foam to slow melting, a practice unheard of 20 years ago. While satellite images provide the big picture, it's these ground-level changes that make the loss tangible for those living with its consequences. Communities on the front lines. Zermatt stands as a case study for how mountain communities adapt to vanishing glaciers. The iconic Swiss resort town built its identity around the Matterhorn and surrounding glaciers, but warming temperatures force reinvention. Local guides report glacier routes changing yearly. The famous Matterhorn Glacier Paradise ski area now covers sections with white tarps to slow melting. What worked for generations no longer applies. Residents describe accelerating changes. Mountain guide Daniel Luggen, who's led climbs near Zermatt for 25 years, notes, "Routes I learned as an apprentice don't exist anymore. Rockfalls increase where ice used to bind the mountains together." Hotel owner Martina Berkeley reports hotter summers altering tourism patterns. Fewer hikers come in July and August now. They say it's too warm for strenuous activity at altitude. Schoolteacher Anya Mahler sees children adapting. Kids today don't associate the Matterhorn with permanent snow like we did. Their normal is different. These personal accounts highlight how climate shifts reshape daily life and traditions. Economic impacts accumulate in unexpected ways. A 2023 University of Zurich study calculated that alpine resorts below 1,500 meters could lose 70% of winter tourism revenue by 2050. Davos spends $2 million annually on artificial snow production, while St. Moritz invested $40 million in high-elevation snowmaking systems. These costs squeeze smaller villages hardest. Gadman, population 250, abandoned plans to revive its ski area after insurers deemed the investment too risky. Traditional cheese-making declines too. Warmer summers allow fewer days for alpine pasture grazing, reducing milk yields by an estimated 15% in some regions. Marcus Reeder, a cheese dairy owner, explains, "My grandfather kept cows above 2,000 meters for 100 days yearly. Now we're lucky to get 70 days before heat stress affects the herd." He notes how the flavors of alpine cheeses are changing as cows graze lower altitude forage. Water availability reshapes daily life. The Gornera River, fed by Zermatt's shrinking glaciers, now runs low by August, 2 months earlier than in the 1990s. Farmers who relied on predictable melt patterns now compete for diminishing supplies. Eric Zenhausen, a fourth-generation dairy farmer in Lotskentel, says, "We used to divert glacier water to our fields all summer. Now we ration by July, and some years, we truck in hay because pasture grass dries up." Hydropower stations face similar strain. Regional plants average 20% lower summer output compared to 1990s levels, according to Swiss Federal Energy Office data. Adaptation costs spiral. The Swiss government allocated $140 million for climate adaptation in mountain regions last year, but needs outpace budgets. Grindelwald spent $12 million building reservoirs to store winter snowmelt after glacier-fed springs became unreliable. Zermatt's project to pipe water from higher glaciers costs $3,500 per meter of pipeline, with 8 kilometers needed. Insurance premiums for mountain properties rose 30% industry-wide since 2015, reflecting increased landslide and flood risks. Projections suggest deeper disruptions ahead. ETH Zurich models indicate some villages below 2,000 meters may become economically unviable within 30 years as water supplies diminish and tourism shifts higher. Abandoned settlements already dot lower valleys. The hamlet of Berglaunen near Grindelwald lost half its population after repeated floods made insurance unaffordable. Glaciologist Matthias Huss warns, "We're seeing positive feedback loops. Less ice means more heat absorption, which means faster melting. Some communities sit in the path of this acceleration." These local stories preview broader water supply challenges. As mountain reservoirs decline, effects cascade downstream to cities and farmlands that rely on alpine water systems. The same glaciers feeding Zermatt streams also supply the Rhone River, which provides drinking water for 2 million people and irrigation for much of Switzerland's vegetable production. What begins as a mountain town's adaptation struggle soon becomes a national resource management issue. In Grindelwald, the Müller family offers a glimpse into the human side of these changes. Their farm, passed down for generations, now faces an uncertain future. Anja Müller explains how her children help ration water for their livestock. They've grown up knowing we can't waste a drop. It's hard to see them take on that responsibility so young, but it's our reality now. Her husband, Peter, adds, "We've had to sell half our herd because we can't sustain them anymore. It's heartbreaking, but we're trying to adapt." Their story reflects the resilience and challenges faced by many mountain families as they navigate an uncertain future. Europe's water tower at risk. The Alps act as Europe's water tower, storing winter snow and ice that gradually melt to feed major rivers like the Rhine, Rhone, Pur, and Danube. These rivers provide drinking water to over 170 million people and irrigate crops from Swiss valleys to Dutch tulip fields. For centuries, this natural reservoir functioned like a giant savings account, releasing water precisely when lowland areas needed it most during hot, dry summers. But now, that system is breaking down. Hydrological monitoring shows summer water flows decreasing significantly. The Rhone River at Lake Geneva carries 20% less water in August compared to 1980s averages. Sections of the Rhine near Basel recorded their lowest flows ever in 2022, forcing cargo ships to reduce loads by 30% to navigate shallow waters. Italy's Po River, which relies on alpine glaciers for 40% of its summer flow, dropped so low in 2022 that seawater intruded 40 kilometers inland, contaminating aquifers used for rice irrigation in Lombardy. Downstream cities are already feeling the strain. Lyon, for example, declared water restrictions in 3 of the last 5 summers as Rhone levels fell. Stuttgart spent €15 million dredging the Neckar River to maintain industrial water intakes when alpine tributaries delivered less flow. Milan rationed water for 125 days in 2022 after the Po Basin received 70% less snowmelt than usual. The Swiss Federal Office for the Environment warns these disruptions will intensify, projecting a 10 to 15% reduction in total alpine water storage by 2040. Changing precipitation patterns compound the problem. While total rainfall hasn't decreased significantly, more arrives as rain instead of snow during winter months. Rain runs off immediately rather than staying stored as snowpack. The Swiss Research Institute for Forest, Snow and Landscape recorded a 30% decrease in snow-covered days below 2,000 meters since 1970. This shift means rivers receive less gradual meltwater in spring and summer, instead experiencing winter flood peaks followed by sharp drops when rains stop. Agricultural regions now struggle with unpredictable water supplies. The Valais Canton, Switzerland's primary wine and apricot growing area, reported a 50% increase in irrigation demands over the past decade as summer droughts intensify. Farmers in Germany's Allgäu region, which depends on alpine-fed streams, lost €25 million in 2022 when depleted waterways couldn't support their dairy operations. French vineyards along the Rhone saw sugar concentrations in grapes spike during recent droughts, producing unbalanced wines that deviate from centuries-old regional styles. Industrial water users are also adapting. Basel's pharmaceutical industry now recycles 35% more water than in 2010 to offset reduced Rhine flows. Hydropower output dropped 7% across Swiss plants last decade during critical summer months, pushing energy prices up 12% in affected regions. The Grand Canal in Austria, which diverts alpine water for power generation, produces 20% less electricity during August than it did in the 1990s despite infrastructure upgrades. Unusual drought pockets are emerging in unexpected places. The Jura Mountains northwest of the Alps, historically rain-rich, recorded their driest 3-year period from 2020 to 2022. Foresters there note beech trees dying on south-facing slopes, a phenomenon previously seen only in Mediterranean climates. Lake Constance, fed by alpine rivers, dropped to its lowest level since record-keeping began in 1868, forcing ferry operators to modify routes. Scientific models predict worsening conditions. HH Zurich projects median summer flow reductions of 25% across alpine-fed rivers by 2050 under moderate warming scenarios. The most severe projections show the Pur and Rhone losing 40% of their summer volumes by 2100. These estimates account for both glacier disappearance and shifting precipitation patterns, a dual threat that current water management systems aren't designed to handle. Groundwater systems show delayed but concerning impacts. France's Rhone Mediterranean Water Agency measured aquifer levels, dropping 1 to 1.5 meters annually in regions recharged by alpine rivers. Overpumping exacerbates the problem. Lyons suburbs extract 15% more groundwater than in 2000 to compensate for reduced river flows. Once depleted, these underground stores may take decades to recover, even if precipitation patterns improve. The agricultural sector faces impossible choices. Italian rice farmers in the Po Valley, who produce half of Europe's risotto rice, now leave 30% of fields fallow during dry years. Swiss dairy cooperatives report milk yields dropping 8 to 12% during heat waves as cows experience heat stress without adequate drinking water. The EU Agricultural Commission estimates alpine water shortages could reduce crop yields in southern Germany by up to 25% within 15 years. Urban water systems are reaching breaking points. Zurich upgraded its water treatment plants to handle turbidity spikes from glacial floods, events that have increased 300% since 1980. Munich built underground storage basins holding 50 million liters to buffer against fluctuating Isar river flows. These adaptations come at a cost. Swiss municipalities now spend 3 times more on water infrastructure than they did 2 decades ago. Tourism operators are also competing for diminishing water resources. Golf courses in Valais prioritize watering greens over fairways during shortages. Spa towns like Lucabad face cancellations when thermal baths can't maintain water levels. These conflicts will only intensify as water becomes scarcer, early signs of a much broader reckoning for Europe's most critical water source. Next, we examine how vanishing snow and ice reshape the continent's iconic winter tourism industry. The collapse of winter tourism. Winter tourism generates $20 billion annually for alpine economies, supporting 400,000 jobs across Switzerland, France, Italy, and Austria. But ski seasons are shrinking as temperatures rise. Since 1970, the average winter season has shortened by 21 days at elevations below 1,500 meters. Resorts at 2,000 meters now lose 5 to 10 ski days per decade on average, according to Meteo Swiss data. The Snow Reliability Index highlights the challenge. Developed by Swiss researchers, this metric calculates how many years out of 10 a resort can operate profitably with natural snow. In 1985, areas above 1,500 meters scored 8 out of 10. Today, that same elevation rates 5/10, with projections showing a drop to 3/10 by 2050. Below 1,200 meters, the index already stands at 1/10, explaining why 42 small Swiss resorts have closed since 2000. Artificial snow production offers a temporary solution. Resorts now spend millions installing snowmaking systems, with over 16,000 snow cannons covering 50% of pistes in the Swiss Alps. Andermatt invested $18 million in snowmaking upgrades last year, while Verbier covers 98% of its ski area with artificial snow. However, these systems have limits. They require water volumes equal to a town of 60,000 people daily, and only function when temperatures stay below -4 degrees Celsius, a threshold increasingly rare in early and late seasons. Operating costs are soaring. Producing artificial snow adds $1,500 per hectare daily, driving lift ticket prices up by 20 to 30% at affected resorts. A 2023 University of Lausanne study found snowmaking now consumes 35% of smaller resorts' operating budgets, up from 12% in 2000. Energy demands are another hurdle. Val d'Isa's snowmaking system uses enough electricity in a season to power 4,000 homes for a year. Lower elevation resorts are disappearing. The Swiss village of Splugen closed its ski lifts in 2019 after 8 consecutive snowless winters. Austria's Kutai resort relocated lifts 300 meters uphill at a cost of €15 million, abandoning lower runs. France's Pyrenees region has lost 31% of its ski areas since 2000, with remaining operators consolidating around higher peaks. The economic ripple effects are stark. Seasonal worker contracts have shortened from 5 to 3 months on average since 2010. SOSFI reports 40% of ski instructors leaving for higher altitude resorts in recent years. Restaurant staff who once relied on winter jobs now face fewer opportunities, with wages dropping by 25% in some areas, according to Swiss employment data. A St. Moritz ski rental operator shared, "We've sold 60% fewer children's skis than a decade ago. Families just aren't coming like they used to." Climate models predict further contraction. The Swiss Snow Research Institute projects reliable snow cover will disappear below 1,500 meters by 2100 under current warming trends. In a high-emission scenario, only 4% of current ski areas will remain viable by century's end, all above 2,500 meters. Even these high-altitude refuges face challenges, as glaciers that currently support summer skiing retreat. Mountain economies are diversifying out of necessity. Zermatt opened a year-round mountain coaster aimed at non-skiers, while Davos shifted focus to medical conferences. These transitions are difficult. Tourism boards report overnight stays declining 8% in diversified resorts compared to 12% in ski-focused areas. Peripheral businesses struggle to adapt. A Verbier hotelier noted, "We installed air conditioning for summer guests, but July temperatures now reach 32 degrees Celsius, too hot for hiking." Insurance costs reflect the risks. Premiums for ski resorts have risen 22% industry-wide since 2018, with insurers requiring climate adaptation plans for coverage. Some operators now purchase weather derivatives, financial instruments that pay out when temperatures exceed thresholds. Switzerland's largest resort group, Vail Resorts, spent $3 million on temperature hedging last season alone. Real estate markets are also shifting. Properties below 1,400 meters now take 18 months longer to sell compared to 2010 averages, while prices stagnate. At higher elevations, prices have risen 30% as buyers seek climate-proof investments. These shifts create new ghost towns. The Austrian village of St. Leonard in Pitztal abandoned plans for a new lift system after insurers deemed the $40 million project unbankable. The human costs are visible in mountain communities. School enrollments have dropped 25% in Swiss villages where ski jobs disappeared. Local governments face budget shortfalls. The municipality of Arosa cut public services by 18% after tourism taxes declined. Pension systems feel the strain too. Austrian ski instructors now retire with 30% less savings than a decade ago due to shorter working seasons. By 2050, researchers predict only resorts above 2,000 meters will reliably offer winter sports, just 25% of current ski areas. This concentration will create overcrowding, with 4 times as many visitors competing for half the terrain. The coming decades will permanently reshape mountain economies, as reliable snow becomes a memory at elevations where winter tourism once thrived, evolved over millennia to thrive in cold, stable conditions. Now warming disrupts these finely balanced systems faster than species can adapt. The Edelweiss, Switzerland's iconic woolly flower, has retreated 100 meters uphill per decade since 1970, according to Bern University studies. But on many mountains, it's running out of elevation. Populations below 3,000 meters declined 60% in 20 years as summers became too hot for its delicate blooms. Specialized species face a race with no finish line as their habitats shrink. The snow voles range contracted by 30% as alpine meadows gave way to shrubs. Swiss National Park researchers found ptarmigan populations dropping 5% annually, their white winter camouflage increasingly mismatched against earlier snowmelt. The Apollo butterfly, already confined to high rock faces, lost 75% of its valley colonies when temperatures exceeded its larvae's survival threshold. For these species, there's no higher ground to escape to. New arrivals further disrupt these fragile systems. Marmots now wake from hibernation 3 weeks earlier, emerging to find scant vegetation. Red deer venture 500 meters higher than recorded in the 1990s, trampling delicate alpine plants. Common ragweed has infiltrated 60% of surveyed alpine pastures since 2005, outcompeting native grasses. Zurich University ecologists measured a 40% increase in non-native plant species above 2,000 meters since 1980. Many carried uphill by warmer winds or hikers' boots. Food chains unravel in unexpected ways. The mountain hare's seasonal coat change, white in winter, brown in summer, now leaves it dangerously visible against late snowfall and early melts. Researchers from Lausanne documented 30% fewer golden eagles in regions where their main prey, the snow hare, declined. Ring ouzels, alpine thrushes that time breeding to snowmelt, now hatch chicks 17 days earlier on average, before enough insects emerge to feed them. Even microbial soil communities shift, accelerating decomposition and releasing stored carbon. Plant communities reorganize visibly. Shrub expansion represents one of the clearest changes. Alpine willows now grow 30% faster and 20% taller than in 1990 measurements. Between 1,800 and 2,500 meters, grasslands shifted to shrub dominance across 65% of monitored areas. This reduces grazing for ibex and chamois, forcing them onto riskier terrain. Switzerland's famous alpine wildflower meadows, carefully maintained by centuries of seasonal farming, declined 20% as traditional grazing patterns become untenable. Insect declines cascade through ecosystems. Zurich researchers counted 60% fewer bumblebees above 2,500 meters compared to 1980 surveys, reducing pollination for alpine flowers adapted to specific bee species. Simultaneously, warmth-loving spiders and beetles appear at unprecedented heights. The Swiss Biodiversity Monitoring Program found 28 new insect species above 2,200 meters in the past decade, competing with, and sometimes preying on, native fauna. Microclimates, once cold refuges, are disappearing. North-facing cirques and shaded valleys that buffered species during warm periods now exceed historic temperature ranges. Recent surveys show 80% of these microhabitats in the Bernese Oberland have warmed beyond their thresholds. Springtails, tiny soil arthropods integral to nutrient cycling, vanished from 40% of their known sites. Researchers describe this as losing the insurance policy that helped species survive past climate fluctuations. Freshwater systems face parallel disruptions. Glacier-fed streams now run warmer. July temperatures in Aletsch tributaries increased 4 degrees Celsius since 1980. This stresses cold water specialists like the alpine bullhead fish, now extirpated from 30% of its range. Meanwhile, warm water parasites proliferate. A 2023 study found 85% of mountain lakes above 2,000 meters now host harmful algae previously limited to lower elevations, remaking aquatic communities in years rather than centuries. Climate zones migrate upward at unprecedented speeds. The alpine zone, defined by constant freezing temperatures at night, has moved 11 meters higher annually since 1990. Plants and animals needing constant cold now crowd shrinking peaks. The Nival Zone, permanent snow, disappeared entirely from mountains below 3,500 meters. What took 10,000 years after the last ice age now occurs in decades, leaving no time for evolutionary adaptation. Some changes prove irreversible. Certain alpine plants evolved to germinate only after specific freeze-thaw cycles. With warmer winters, their seeds lie dormant indefinitely. Swiss Federal Institute surveys identified 12 plant species that produced no seedlings in the past 5 years. The Engadine rock jasmine, found on just 3 Swiss peaks, hasn't flowered since 2018. Such losses reduce genetic diversity that future adaptation might require. These transformations beg the question, what happens when no higher ground remains? On isolated peaks like the Taschhorn, researchers already document faunal collapse as species run out of migration room. The Swiss Federal Office for the Environment estimates 15% of alpine endemics may disappear by 2050, taking with them unique genetic lineages evolved over ice ages. Unlike ski resorts or water systems, these losses admit no technological fix. Once gone, they won't return. Unexpected economic consequences. Hydropower producers face mounting challenges as glacier melt patterns shift. The Swiss energy company Axpo reported a 5% drop in summer hydroelectric generation since 2010 across its alpine plants. Changing water flows are the culprit. Glaciers now release peak melt in June instead of August, leaving reservoirs depleted during high-demand periods. The Grande-Dixence complex, Europe's tallest gravity dam, operated at just 73% capacity last summer despite heavy spring melting. Infrastructure designed for gradual melt struggles to adapt. Older plants like the Oberhasli system require $300 million in upgrades to capture earlier runoff. These shifts in glacier behavior act like a fragile domino effect, destabilizing energy markets and rippling through the broader economy. Agriculture adapts at considerable cost. Valais vineyards now irrigate 40% more land than 20 years ago as summer droughts intensify. The region's famous fendant grapevines suffer heat stress above 30 degrees Celsius. Temperatures now reach 25 days per season compared to 8 days in the 1990s. Winemakers like Domaine de Muses spend €15,000 per hectare installing sunshading nets, while others experiment with heat-resistant grape varieties. Some south-facing slopes become unsuitable entirely. The Terraces de Chaune cooperative abandoned 12 hectares of premier cru vineyards last year due to consistent overripeness in grapes. Insurance markets reflect growing risks. Swiss Re data shows climate-related property claims in alpine regions rising 9% annually since 2015. The 2020 Bondo landslide, triggered by permafrost thaw, cost €41 million in insured damages. These events prompt rate hikes. Premiums for mountain properties increased 30% in vulnerable areas last year. Some insurers now exclude permafrost-related damage entirely, while others require expensive geological surveys. The Swiss construction industry feels the impact. Building permits in areas with permafrost fell 40% as insurance becomes unattainable. Transport infrastructure requires massive reinvestment. The Gotthard Base Tunnel, Europe's longest rail tunnel, now needs €2 billion in climate adaptations despite opening in 2016. Engineers discovered groundwater infiltration exceeding projections by 300% as surrounding glaciers retreat. High-altitude roads fare worse. The Julia Pass requires resurfacing every 3 years instead of 10 due to increased freeze-thaw cycles. The Swiss Federal Roads Office estimates climate-related maintenance costs will consume 15% of its budget by 2025, up from 6% in 2010. Winter sports manufacturers diversify or decline. French ski producer Rossignol saw alpine equipment sales drop 25% since 2015, forcing expansion into Nordic and backcountry products. Bindings now require adjustment ranges accommodating both icy artificial snow and variable natural conditions. Smaller specialty firms struggle. Swiss ski maker Stockley cut production 30% and laid off 15% of staff last year. The economic ripples extend beyond manufacturers. Tuning shops report shorter equipment lifespans as abrasive artificial snow wears bases faster. Unique alpine industries face existential threats. Traditional cheesemaking depends on summer alpine grazing, but pastures now dry out earlier. The AOP system protecting Swiss Gruyere requires 70% of milk from grass-fed cows, a standard becoming harder to meet. Dairies like Letovaz report 20% lower summer yields as cows experience heat stress above 25 degrees Celsius. The famous Bernese alpine cheese maker Rugseg reduced production from 200 to 120 wheels annually as optimal aging conditions become rarer in warming cellars. Construction standards evolve with the climate. Permafrost foundations now require deeper pilings. The new avalanche center in Davos cost 30% more than planned due to additional ground stabilization. Roof designs changed too. Snow load requirements decreased 15% at mid-elevations, while rainfall runoff calculations increased 20%. The Swiss Society of Engineers estimates construction costs in mountain towns will rise 18% by 2030 solely due to climate adaptations. Energy markets show cascading impacts. Reduced hydropower forces greater reliance on imports. Switzerland purchased 25% more German coal power last winter during low reservoir levels. Electricity prices in alpine regions now spike unpredictably. December 2022 saw a 300% price surge when low hydro reserves coincided with cold snaps. Some industries respond by relocating. 2 aluminum plants moved operations from Valais to Norway citing energy reliability concerns. Projections paint a concerning picture. The Swiss Federal Office of Energy anticipates hydropower generation dropping 15% by 2050 under current warming trends. Agricultural output could decline 20% in some valleys as traditional crops become unviable. The Swiss Re Institute estimates climate-related costs could reach 3% of Switzerland's GDP annually by 2060, 3 times current levels. These economic transformations extend beyond the Alps. The Andes and Himalayas experience similar disruptions to hydropower, agriculture, and infrastructure, but at different scales and timelines. While the Alps currently face the most rapid changes, their struggles preview challenges awaiting mountain regions worldwide. The speed of alpine glacier retreat makes Switzerland a case study in climate economics, with lessons for all mountainous areas facing warming temperatures. Global perspective. Alps versus Andes versus Himalayas. The Swiss Alps represent one part of a global phenomenon, mountain glaciers disappearing at unprecedented rates. While the Alps lose ice faster than any other major range, similar crises unfold across the Andes and Himalayas, each shaped by unique geography and human reliance. Between 2015 to 2019, mountain glaciers lost 298 billion tons of ice annually, enough to cover Switzerland in 7 meters of water each year. The Andes face the most immediate water threats. Bolivia's Chacaltaya Glacier, once home to the world's highest ski resort, vanished entirely by 2009. Peru's Quilquea ice cap, the largest tropical ice mass, retreats 60 meters annually, 10 times faster than in the 1970s. These losses directly impact 30 million people. Lima, a desert city of 10 million, relies on Andean glaciers for 40% of its water. The Peruvian government spends $120 million annually on artificial lakes to store dwindling meltwater. In Bolivia's Altiplano, farmers abandon quinoa fields as glacial streams dry up. 60% of smallholders reported crop losses from water shortages in 2022. One farmer described watching his family's fields turn to dust, forcing them to migrate to La Paz in search of work. The Himalayas, containing 12,000 cubic kilometers of ice compared to the Alps 100, experience slower percentage losses, but face immense consequences due to their scale. Eastern Himalayan glaciers lose 0.5 meters of ice thickness annually, while western areas lose nearly double that. Nepal's Ngozumpa Glacier has developed over 100 new meltwater lakes since 1995, threatening downstream communities with sudden floods. In India, the Chipka Hydro project saw power generation drop 30% over the last decade as river flows became erratic. A Sherpa guide in the Khumbu region noted how rapidly shifting glaciers have rendered traditional trade routes unreliable, endangering both livelihoods and lives. Water politics further complicate Himalayan adaptation. China's dam building on the Mekong affects downstream Laos and Cambodia, while India and Pakistan dispute rights to the Indus River. Unlike the Alps, where water management crosses relatively stable borders, Himalayan waters flow through geopolitically tense regions. The International Center for Integrated Mountain Development recorded 35 significant water disputes in the Hindu Kush Himalaya since 2010. The Alps, though smaller in scale, face the fastest percentage losses, 2% of remaining ice annually. Their lower average elevation of 3,000 meters makes them more vulnerable to warming, with glaciers at this height losing 3 times more mass per degree of warming than those at 5,000 meters. Swiss engineers have resorted to covering glaciers like Rhone with reflective blankets to slow melting. Meanwhile, alpine communities adapt economically. Ski instructors transition to summer hiking guides, and infrastructure like train tunnels is reinforced against permafrost thaw. A Swiss villager lamented the loss of transhumance farming traditions, saying, "It's not just the ice disappearing, it's our way of life." Economic impacts vary across regions. In the Andes, agricultural collapse looms. Peru has already lost 30% of its high-altitude potato varieties. In contrast, Himalayan hydropower projects face long-term risks, such as Nepal's $2.4 billion Upper Tamakoshi plant, which operated at just 60% capacity last dry season. The Alps experience more diversified effects, from disappearing ski resorts to buckling infrastructure. Adaptation strategies reflect these contrasts. Peruvian farmers revive ancient stepped pond systems called cocas to capture erratic rainfall, while Bhutanese workers dynamite glacial lakes to prevent catastrophic floods, a solution unthinkable in the tourism-dependent Alps. In India's Rohtang Pass, communities now truck water during dry periods at 30 times the cost of former glacier-fed supplies. Despite regional differences, common challenges emerge. All face accelerated water scarcity. The Andes earliest due to smaller glaciers, followed by the Alps, and eventually the Himalayas. Glacial flood risks surge in all regions, with Switzerland projecting a 300% increase in GLOF events by 2050, mirroring Nepal's current crisis. Economic diversification proves universally difficult, whether replacing Bolivian quinoa exports or Swiss ski tourism. Projections reveal a sobering convergence. Even if warming stays below 2 degrees Celsius, the Alps could lose 70% of their remaining ice by 2100, the Andes 80%, and the Himalayas 45%. At current emissions, complete deglaciation becomes likely for the Alps and Andes, with the Himalayas retaining only high elevation remnants. Yet, the Himalayas' vast starting volume means even slower melting produces greater absolute water disruptions, while the Andes face the most immediate human crises. Each range offers distinct lessons. The Alps demonstrate advanced economy adaptation, the Andes highlight survival challenges for vulnerable populations, and the Himalayas illustrate transnational water management dilemmas. Together, they show no mountain range escapes transformation. Only the timeline and consequences vary. The countdown to glacier extinction. Glaciologists now predict the Great Aletsch Glacier, which holds 11 billion tons of ice, will fragment into 3 sections by 2040 under moderate emission scenarios. By 2100, even its thickest sections, currently 3,600 meters deep, could vanish entirely. These projections rely on advanced methods like satellite altimetry to measure ice loss, ground-penetrating radar to map bedrock, and temperature sensors to track melting at various elevations. Zurich's models show the Morteratsch Glacier could disappear by 2070 at current melt rates, though optimistic scenarios might extend its life to 2090. Under the UN's Intermediate Emissions Pathway, RCP 4.5, 70 to 80% of alpine ice volume will be gone by 2100. In a high-emission scenario, RCP 8.5, less than 5% would remain. Melting accelerates as glaciers shrink, driven by reduced albedo and shifting geometries. Some glaciers have already passed critical thresholds. The Pizol Glacier, reduced to just 0.06 square kilometers, was declared dead in 2019. The Tskierva Glacier has lost 98% of its volume since 1850 and is now classified as functionally extinct, with no significant accumulation zone left. Despite efforts like covering sections of the Rhone Glacier with protective blankets each summer, it still loses 8 meters of length annually. These examples highlight that once certain tipping points are crossed, interventions can only delay the inevitable. Temperature thresholds vary by glacier, with those below 3,000 meters and on shallow slopes declining fastest. The San Glacier, which once connected two ski areas, split in 2022 when its central portion melted through. This fracturing exposes more edges to warm air, accelerating its demise. Darkening surfaces also hasten melting. On the Aletsch Glacier, summer dust accumulation has reduced reflectivity by 15% compared to the 1980s. Switzerland has begun memorializing its vanishing glaciers. In 2019, hundreds attended a funeral for the Pisol to mark its official declassification as a glacier. Hikers now encounter plaques marking former ice fronts, such as one near Grindelwald that reads, "Here stood the lower glacier until 2008. In Valais, annual marches of disappearance trace shrinking glacier perimeters." These ceremonies document changes that typically unfold over geologic timescales. For instance, the Trift Glacier retreated 1,200 meters between 2020, a shift recorded on a commemorative plaque. Scientific data confirms these irreversible changes. Core samples from the Gorner Glacier show annual layers thinning dramatically, from 14 meters of accumulation in 1950 to just 5 meters today. Radioisotope dating reveals some glaciers now expose bedrock last seen during Europe's medieval warm period, 800 years ago. Even if warming stopped today, delayed thermal effects would still cause the Alps to lose 40% of their remaining ice. Worst-case scenarios predict staggering losses. Zurich's unmitigated emissions model forecasts 95% of alpine glaciers gone by 2100, including iconic ones like those on Eiger's north face. Visualizations depict the Matterhorn nearly ice-free by the 2080s. Smaller glaciers face the fastest decline. The Sardona Glacier, now just 0.4 square kilometers, is shrinking by 7% annually and may disappear by 2035. Similarly, St. Annapurna has lost the critical mass needed to sustain meltwater flow. Glaciologists call these walking dead glaciers, technically still present but beyond recovery. Mid-sized glaciers are also in peril. The Zinal Glacier near Verbier recedes 35 meters annually, with its 6-kilometer length projected to have by 2060. This decline threatens the Navissance River system, which supplies water to 12 downstream villages. Hydrologists compare these glaciers to punctured water towers, holding less water and releasing it unpredictably. Even high-altitude glaciers are not immune. Monte Rosa's Grents Glacier, at 4,200 meters, has retained 85% of its mass since 2000, but its melt rates have recently tripled. Researcher Matthias Huss warns, the term perpetual ice no longer applies even at 4,000 meters. We're seeing measurable thinning where we once assumed stability. Critical thresholds help predict which glaciers will disappear first. Below 300 meters thick, glaciers can no longer flow downhill to replenish losses, instead stagnating and melting in place. The Trient Glacier reached this point in 2018, its snout now a crumbling ice cliff retreating uphill. Glaciers smaller than 0.5 square kilometers rarely survive past 2050 in model projections. Communities are adapting to these changes. Zermatt now plans for ice-free summers, shifting from glacier hikes to other attractions. Hydropower operators redesign intake systems for erratic meltwater flows, local solutions and adaptations. Swiss communities are finding increasingly creative ways to manage glacier loss, despite facing significant physical and financial constraints. One of the most visible efforts involves protective coverings, white geotextile blankets that shield 0.5% of Switzerland's remaining glacier area each summer. At the Rhone Glacier, workers unfurl 100,000 square meters of these synthetic fibers annually, reducing melt by 60% in covered sections. The process is labor-intensive and costly, requiring helicopter transport and manual installation over unstable ice. While effective locally, these measures are limited in scale. Covering just Switzerland's largest 20 glaciers would require an area of fabric larger than Manhattan. Another innovative solution comes in the form of water storage systems designed to compensate for the loss of glacial buffers. In Zermatt, new underground systems store 60 million liters of winter snowmelt for summer use, equivalent to 20 Olympic pools. These systems ensure a steady water supply during drier months, helping communities adapt to shifting seasonal patterns. Meanwhile, smaller villages are rediscovering ancient techniques. In the Lochen Valley, medieval bysses, wooden trough systems, have been revived to divert high-elevation streams to pastures, blending historical ingenuity with modern necessity. Relocation plans for vulnerable settlements highlight the emotional and logistical challenges of adapting to glacier retreat. In Pontresina, Switzerland's first glacier retreat adaptation strategy identified 47 buildings at risk due to thawing permafrost. Construction has begun on a new neighborhood 500 meters uphill, with reinforced foundations to withstand unstable ground. However, the plan has divided the community. Only 23% of residents approved the relocation in a municipal vote, with many elderly homeowners reluctant to leave family properties. This debate underscores the human cost of climate adaptation, as communities grapple with a tension between preserving heritage and ensuring safety. Economic diversification efforts reflect the broader struggle to adapt to a changing landscape. Zermatt has invested in converting glacier hiking trails into via ferrata climbing routes, while Davos has shifted its focus from winter sports to hosting medical summits. These changes aim to sustain tourism and local economies, but success varies. For example, the Glacier Express Railway now offers climate change tours with glaciologist guides, though ticket sales cover only 40% of operating costs. Traditional industries face similar challenges. Alpine cheesemakers, like the Eiger Dairy near Grindelwald, now import 30% of their milk from lowland farms as high pastures dry up, a stark reminder of the cascading effects of glacier loss. Hydropower operators are also adapting, though not without difficulty. The Grande-Dixons complex spent €170 million retrofitting intake tunnels to handle sediment from glacial erosion, a costly but necessary adjustment. Smaller plants, like Furpical, face harder choices, balancing summer generation against winter ice dam risks. These adaptations often come with trade-offs, as new systems reduce output or require constant manual adjustments. Community planning increasingly reflects the inevitability of change. In Pontresina, school curriculums now include climatology, preparing children for a future shaped by glacier loss. Zermatt has retrained former glacier guides as climate interpreters, offering tours that explain the disappearing ice to visitors. These shifts represent a growing acceptance of irreversible transformations. A 2023 University of Bern survey found that 68% of Alpine residents now view glacier loss as permanent, up from 41% in 2015. Scientific interventions continue to test the limits of what's possible. Zurich's experimental ice stitching project uses patented textiles to refreeze meltwater on the Morteratsch Glacier, achieving 12% regeneration in test areas. However, the technique is prohibitively expensive, costing €500 per square meter. Other efforts, like cloud seeding near Davos, to enhance snowfall, have shown inconsistent results, with only an 8% increase in winter precipitation. These efforts, while innovative, remain constrained by physics and finance. Protective blankets and artificial snow can buy time, but they cannot reverse the broader trends. The Swiss Federal Institute for Forest, Snow and Landscape Research estimates that current measures might preserve 15 to 20% of remaining ice volume beyond natural trajectories, if global emissions decline rapidly. Without such reductions, most adaptations will become economically unsustainable by 2050. As communities adapt, they also document what is being lost. The Unturtle Museum near Andermatt now preserves glacier-dependent lifestyles through holograms and oral histories, while festivals like the Fiche Glacier Festival incorporate themes of impermanence, featuring melting ice sculptures that dissolve over the event's duration. These cultural efforts acknowledge that some heritage cannot be physically preserved, only remembered differently. While farmers switch to drought-resistant crops, even ski resorts adjust their messaging, emphasizing guaranteed snow rather than natural glaciers. Municipalities commission glacier autopsies to prepare for future risks, such as unstable slopes or new floodplains. Brig recently spent €2 million rerouting roads to avoid areas likely to destabilize as ice disappears. While some glacier loss is inevitable and these efforts aim to mitigate, Swiss communities are finding increasingly creative ways to manage glacier loss, despite facing significant physical and financial constraints. One of the most visible efforts involves protective coverings, white geotextile blankets that shield 0.5% of Switzerland's remaining glacier area each summer. At the Rhone Glacier, workers unfurl 100,000 square meters of these synthetic fibers annually, reducing melt by 60% in covered sections. The process is labor-intensive and costly, requiring helicopter transport and manual installation over unstable ice. While effective locally, these measures are limited in scale. Covering just Switzerland's largest 20 glaciers would require an area of fabric larger than Manhattan. Another innovative solution comes in the form of water storage systems designed to compensate for the loss of glacial buffers. In Zermatt, new underground systems store 60 million liters of winter snowmelt for summer use, equivalent to 20 Olympic pools. These systems ensure a steady water supply during drier months, helping communities adapt to shifting seasonal patterns. Meanwhile, smaller villages are rediscovering ancient techniques. In the Lochen Valley, medieval bysses, wooden trough systems, have been revived to divert high-elevation streams to pastures, blending historical ingenuity with modern necessity. Relocation plans for vulnerable settlements highlight the emotional and logistical challenges of adapting to glacier retreat. In Pontresina, Switzerland's first glacier retreat adaptation strategy identified 47 buildings at risk due to thawing permafrost. Construction has begun on a new neighborhood 500 meters uphill, with reinforced foundations to withstand unstable ground. However, the plan has divided the community. Only 23% of residents approved the relocation in a municipal vote, with many elderly homeowners reluctant to leave family properties. This debate underscores the human cost of climate adaptation, as communities grapple with a tension between preserving heritage and ensuring safety. Economic diversification efforts reflect the broader struggle to adapt to a changing landscape. Zermatt has invested in converting glacier hiking trails into via ferrata climbing routes, while Davos has shifted its focus from winter sports to hosting medical summits. These changes aim to sustain tourism and local economies, but success varies. For example, the Glacier Express Railway now offers climate change tours with glaciologist guides, though ticket sales cover only 40% of operating costs. Traditional industries face similar challenges. Alpine cheesemakers, like the Eiger Dairy near Grindelwald, now import 30% of their milk from lowland farms as high pastures dry up, a stark reminder of the cascading effects of glacier loss. Hydropower operators are also adapting, though not without difficulty. The Grande-Dixons complex spent €170 million retrofitting intake tunnels to handle sediment from glacial erosion, a costly but necessary adjustment. Smaller plants, like Furpical, face harder choices, balancing summer generation against winter ice dam risks. These adaptations often come with trade-offs, as new systems reduce output or require constant manual adjustments. Community planning increasingly reflects the inevitability of change. In Pontresina, school curriculums now include climatology, preparing children for a future shaped by glacier loss. Zermatt has retrained former glacier guides as climate interpreters, offering tours that explain the disappearing ice to visitors. These shifts represent a growing acceptance of irreversible transformations. A 2023 University of Bern survey found that 68% of Alpine residents now view glacier loss as permanent, up from 41% in 2015. Scientific interventions continue to test the limits of what's possible. Zurich's experimental ice stitching project uses patented textiles to refreeze meltwater on the Morteratsch Glacier, achieving 12% regeneration in test areas. However, The technique is prohibitively expensive, costing €500 per square meter. Other efforts, like cloud seeding near Davos to enhance snowfall, have shown inconsistent results, with only an 8% increase in winter precipitation. These efforts, while innovative, remain constrained by physics and finance. Protective blankets and artificial snow can buy time, but they cannot reverse the broader trends. The Swiss Federal Institute for Forest, Snow and Landscape Research estimates that current measures might preserve 15 to 20% of remaining ice volume beyond natural trajectories, if global emissions decline rapidly. Without such reductions, most adaptations will become economically unsustainable by 2050. As communities adapt, they also document what is being lost. The Unturtle Museum near Andermatt now preserves glacier-dependent lifestyles through holograms and oral histories, while festivals like the Fiche Glacier Festival incorporate themes of impermanence, featuring melting ice sculptures that dissolve over the event's duration. These cultural efforts acknowledge that some heritage cannot be physically preserved, only remembered differently. Eyes from space. Satellite evidence. Satellites provide an unparalleled view of glacial changes too vast to grasp from the ground. The European Space Agency's Sentinel, 2 satellites capture weekly images of the Alps at 10-meter resolution, while NASA's Landsat program offers decades-long comparisons. These eyes in the sky do more than map surface area. They measure ice thickness with radar altimetry, snow cover through spectral analysis, and even subsurface meltwater using microwave sensors. Since 2016, Switzerland's GLAMOS program has combined satellite data with ground measurements to produce monthly glacier health reports as precise as tracking human vital signs. Time-lapse imagery reveals changes invisible to seasonal visitors. A 2023 ESA sequence of the Aletsch Glacier shows its ice front retreating 3.7 kilometers since 1985, leaving behind a barren moonscape of grey moraine. Elevation changes are even more striking. NASA's ERT-2 laser altimeter recorded the Gorner Glacier thinning by 12 meters vertically between 2018 and 2022. Satellites also uncover hidden transformations, like the 137 new glacial lakes spotted in the Bernese Alps since 1990. Some lakes are fleeting. A lake near the Grunhorn Glacier vanished overnight in 2019 when its ice dam collapsed, an event captured by Sentinel-1 radar scans. Old data gains new meaning with modern techniques. Machine learning applied to 1970s Corona Spy satellite imagery revealed Swiss glaciers lost 22% more mass during that decade than previously estimated. Zurich scientists recently developed a method using shadows in satellite photos to calculate daily melt rates, showing the Morteratsch Glacier lost 10 centimeters of ice thickness during a single August 2022 heatwave. Another team tracks microscopic algae blooms on glacier surfaces through hyperspectral imaging. These darkening growths now accelerate melting by 13% compared to the 1990s, according to findings published in PNAS. Mass balance calculations have advanced significantly with satellite data. Traditional methods relied on sparse ground measurements, but satellites now provide comprehensive coverage. The German Aerospace Center's Tandem X mission uses twin radar satellites to create elevation models accurate to within 1 meter, showing Swiss glaciers losing 1.5 meters of thickness annually since 2010, double the rate of the 1990s. NASA's GRACE-FO satellites detect subtle gravity changes as ice melts, aligning with Swiss field studies that confirmed 2022 set a record for mass loss, with 6% of remaining glacier volume disappearing in a single year. Seasonal patterns emerge clearly from orbital observations. Winter snow accumulation, critical for glacier survival, now lasts 23 fewer days on average compared to 1980s satellite records, according to University of Zurich analyses. Summer melting periods have extended by 17 days over the same span. ESA's Cryosat radar shows late summer ice surfaces are now 40% rougher than in the 1990s due to increased meltwater channels and crevasses. Sentinel-3 data generates weekly melt probability maps, showing red zones, indicating certain melting, now cover 65% more area each summer than in 2016. Combining sensors improves data reliability. Cloud-penetrating radar from Sentinel. One supplements optical imagery when storms obscure views. Infrared sensors on NASA's Terra satellite track surface temperatures, identifying cold ice reserves that might resist near-term melting. Ground control points verify satellite findings. GLAMO's technicians placed 2,800 reflective targets across Swiss glaciers for calibration, achieving 3 cm vertical accuracy. The clearest revelations concern total ice loss. A 2022 study in remote sensing of environment combined 6 satellite datasets to calculate that Switzerland's glaciers have lost 45 cubic kilometers of ice since 2000, equivalent to 18 million Olympic swimming pools. The losses are accelerating, with annual melt rates increasing 57% between 2010 and 2020 compared to the previous decade. Some smaller glaciers have disappeared entirely. Satellite imagery confirmed 127 named glaciers under 0.1 square kilometers vanished between 2016 and 2021. Regional variations are also apparent. The Bernese Alps lost ice fastest, at 1.2 meters of thickness annually, while higher elevation Valais glaciers averaged 0.8 meters. Accumulation zones, where snowfall traditionally replenished losses, are shrinking. Satellite snow cover maps show these areas have contracted by 30% since 2000. The Findelen Glacier's accumulation zone retreated 400 meters upslope in just 20 years, pushing glaciers toward irreversible decline. Satellites also capture human interventions. High-resolution Maxar images show white glacier blankets covering 0.6 square kilometers of the Rhone. Glacier each summer, though surrounding unprotected ice continues retreating at 8 meters annually. Before and after images of the Triftsee Reservoir highlight how engineered dams attempt to replace lost glacial water storage, with its expanded capacity now holding 40% more meltwater runoff from the shrinking Trift Glacier. The satellite record confirms an undeniable acceleration. Annual ice loss rates tripled between 2000 and 2020 compared to 1850 to 2000 averages, according to Nature, published comparisons of modern data with historical maps. These orbital perspectives connect high-altitude changes to downstream consequences, like the Rhone River turning turquoise with fine rock flower weeks earlier than in the 1980s, or sediment plumes from glacial rivers extending 15 kilometers into Lake Geneva, threatening aquatic ecosystems. From space, the story of glacial decline becomes impossible to ignore. Downstream domino effects. The shrinking glaciers of the Alps disrupt water systems across Western Europe long before reaching the ocean. Glacial meltwater traditionally fed rivers during dry summers, acting as natural reservoirs that released steady flows when rainfall declined. Now, this centuries-old hydrological rhythm falters. Peak melt arrives months earlier, leaving less water when cities and farms need it most. The Rhone River carries 30% less water past Lyon during August compared to 1980s averages, while the Rhine at Basel shows 25% lower September flows. These shifts permanently alter the continent's water clock, with cascading effects on industries, agriculture, and daily life. Low river levels first cripple navigation on major shipping routes. In 2018, Rhine barges reduced cargo by 40% for 132 days, costing German industry €5 billion in surcharges. Near Kobe, operators now dredge 300 truckloads of sediment weekly to maintain navigable depths. Siemens Energy cancelled turbine deliveries in 2022 when barges couldn't pass this choke point. Swiss pharmaceutical giant Roche, facing similar disruptions, built new logistics hubs in Antwerp, adding 15% to supply chain costs. These adjustments highlight how industries reliant on river transport must now absorb higher costs and logistical uncertainty. Industrial water users face equally stark challenges. BASF's Ludwigshafen complex, the world's largest chemical plant, depends on Rhine water for both cooling and transport. During low-flow periods, managers must prioritize one function over the other, disrupting operations. French nuclear plants along the Rhône reduced output 12 times last summer when river temperatures exceeded 25 degrees Celsius, too warm for effective reactor cooling. EDF estimates these climate-related losses cost €330 million annually, prompting discussions about relocating plants to coastal areas where seawater cooling is feasible. Agriculture, too, struggles to adapt. Burgundy vineyards now install costly drip irrigation systems, a €12,000 per hectare investment that many small growers cannot afford. In Provence, the Lac de Seraponcon reservoir dropped 28 meters in 2022, forcing farmers to abandon 15% of irrigated fields. Italy's Po River Basin, where alpine sources provide 40% of summer flow, lost 60% of rice paddies during 2022's record drought. These losses ripple through rural economies, leaving farmers with fewer options and mounting debts. Municipal water systems also strain under these changes. Zurich invested €45 million in filtration upgrades to handle increasingly turbid glacial floodwaters, which now occur 3 times annually instead of once a decade. Geneva's tap water contains 40% more mineral sediment as melting glaciers grind bedrock faster. Smaller towns face harsher realities. Visp in Valais rationed water for 47 days last summer, banning non-essential uses like car washing. The Swiss Water Association reports 120 municipalities drafting emergency plans for glacier-free futures. These disruptions extend beyond infrastructure to personal lives. In Visp, a local farmer, Hans, described how water rationing forced him to choose between irrigating his crops or providing water for his livestock. "We've always relied on the glaciers," he said. "Now, I don't know how we'll manage if this keeps getting worse." Transboundary tensions also rise along shared rivers. France and Spain dispute management of the Tech River, fed by Pyrenean glaciers retreating 50% faster than alpine ones. Switzerland's unilateral water releases during droughts draw complaints from downstream German cities. "We can't sacrifice hydropower generation to solve Berlin's water problems," remarked a Swiss energy official during confidential negotiations. Hydropower systems face mounting strains. The Grand Maison Dam in France operated at 62% capacity last summer despite early meltwater surges. Operators must balance retaining water for winter electricity with releasing it to sustain river ecosystems. Switzerland's hydropower output dropped 7% during critical summer months over the past decade, pushing electricity prices up 12% in affected regions. Groundwater depletion compounds these issues. The Rhône Mediterranean Water Agency measured aquifers dropping 1.5 meters annually in areas historically recharged by glacial rivers. Lyon suburbs now extract 25% more groundwater than in 2000 to compensate for reduced river flows, a stopgap measure that risks long-term depletion. These interconnected disruptions reveal a hard truth. Europe built its water-dependent civilization during an anomalously stable climatic period. The next decades will test whether engineered systems can compensate for nature's lost ice reservoirs. As industries restructure and communities adapt, they follow patterns first set by species retreating uphill, except humans have nowhere left to climb. Surprising secondary impacts. Glacier loss triggers a cascade of secondary impacts that ripple through ecosystems, economies, and cultures, reshaping the Alps in ways both visible and hidden. These changes carve the landscape like nature's forgotten diaries, revealing stories long buried and creating new, often bizarre, challenges. Geological instability. As ice retreats from slopes it supported for millennia, entire mountainsides become unstable. The 2017 Bondo landslide, where 3 million cubic meters of rock collapsed after warming permafrost lost its adhesive ice, is a stark example. Swiss monitoring systems now record 60% more major rock falls annually compared to 1990s averages. Even the Matterhorn sheds about 1,000 cubic meters of rock yearly, forcing climbing guides to constantly adjust routes. Shifting borders. Melting glaciers redraw national boundaries. The Italy-Switzerland border, once defined by the Lys Glacier, now shifts as the ice splits into separate masses. Surveyors meet biennially to remeasure the frontier, with the 2023 adjustment moving the line 55 meters westward. Similarly, France gains roughly 500 square meters annually as the Glacier d'Argentière retreats, requiring updates to customs posts and avalanche rescue jurisdictions. Unearthed artifacts. Melting ice reveals time capsules from across centuries. A 2020 melt exposed a crashed U.S. military plane near the Goli Glacier, while Roman era coins surfaced near the Theodule Pass. These discoveries, while fascinating, underscore the dramatic transformation of landscapes where ice once persisted for generations. Ecological shifts. Hydrological changes create strange new ecosystems. The Mossa River below the Aletsch Glacier now runs warm enough for invasive signal crayfish, which outcompete native species. Glacial streams host 50% fewer insect species than in 1980, but Mediterranean species now appear above 1,000 meters. The retreat of the Trift Glacier even created a lake that supports Arctic char, introduced accidentally by anglers' boots. Cultural disruptions. Traditional glacier ski races like Switzerland's Inferno event face cancellations or route changes. The original 1928 course became impassable in 2018. The UNESCO-listed Jungfrau Railway contends with destabilization as the Eiger Glacier's retreat undermines its North Wall base. Even alpine art evolves, as the glacier blue pigment once derived from natural glacial flour now requires artificial mixing. Economic oddities. Melting glaciers create unexpected financial challenges. Swiss Re calculates that destabilized slopes increase some insurance risks by 300%. Ski resorts now list glacier assets as depreciating property, with Andermatt reporting a 7% annual decline in glacier value since 2015. The Swiss Federal Inventory classifies 104 glaciers as economically non-viable, where protection costs outweigh benefits. Historical rediscoveries. Closed alpine passes reopen after centuries. The Schneidjoch in the Bernese Alps revealed artifacts from warm periods between 2000 BC and AD 1000, while Norway's Lendbreen Pass yielded Viking trade items. These finds rewrite historical understanding of mountain mobility. Military hazards. Melting ice exposes wartime remnants. French and Swiss bomb disposal teams handled 31 calls last summer to remove live World War II munitions. Austria's Pasteur's Glacier revealed a 1943 fighter cockpit with human remains still strapped inside. The Swiss Army now trains troops to identify and report such dangers. Technological failures. Scientific instruments struggle to adapt. The Swiss Permafrost Monitoring Network reports 12% of sensors rendered useless as ice wedge melt distorts measurements. Glacier monitoring poles installed just 5 years ago now dangle precariously over voids, while satellite calibration suffers as glacier-mounted reflectors require constant repositioning. Microclimate oddities. Localized changes defy expectations. Some north-facing cirques retain cold air so effectively that new, permanent ice forms, confusing long-term monitoring. Elsewhere, ice caves collapse unpredictably, and the Mer de Glacé's famed ice grotto now requires artificial refrigeration despite sitting atop what was Europe's largest glacier in 1850. These unpredictable consequences reveal how deeply glaciers are woven into the fabric of mountain life. As the ice disappears, it unravels ecosystems, economies, and histories, leaving behind a transformed landscape that challenges our understanding of stability. The melting Alps will impact your life in ways that might surprise you. These changes hit grocery bills, tap water, vacation plans, and even where people choose to live. The glaciers currently providing 40% of Europe's summer fresh water are vanishing faster than predicted, and the effects ripple far beyond mountain villages. Your water costs will rise as utilities adapt. Cities like Lyon and Milan already impose summer water restrictions, with households paying 15 to 20% more during peak drought months. The Rhine River's low water levels in 2022 spiked German water bills by an average of €85 per household, a cost passed directly to consumers. Water-intensive products like beer and bottled beverages face price hikes. Heineken announced a 3% increase last year, specifically citing alpine water scarcity. Supermarket shelves reflect these changes. Italian risotto rice, 90% grown in the glacier-fed Po Valley, now costs 40% more than 5 years ago after repeated drought-reduced harvests. Swiss chocolate producers like Lindt pay premiums for mountain spring water needed for their recipes. Even basics like milk show upward pressure. Alpine dairy regions produced 8% less last summer due to heat-stressed cows and parched pastures. Insurance markets also adjust. German home insurance premiums rose 30% in regions prone to Rhine flooding, while Swiss health insurers added heat stress coverage riders. Travel insurance costs 15% more for alpine trips as companies factor in cancellations from extreme weather. These increases appear on statements as line items like climate adjustment fees, a trend expected to intensify. Real estate markets shift unpredictably. Apartments in water-stressed cities like Stuttgart now sell for less than comparable units in water-secure areas. Conversely, high-altitude properties in the Alps appreciate as buyers seek climate havens. A studio in Zermatt costs 25% more than 5 years ago. Coastal and mountain regions face opposite valuation pressures as environmental changes rewrite desirability calculations. Migration patterns reveal indirect effects. Portuguese construction workers who once summered in Swiss resorts now stay home as projects slow. The Swiss construction sector contracted 12% last year amid climate uncertainty. Meanwhile, wealthy northern Europeans buy alpine properties as summer heat alters living preferences. Valet real estate agents report 30% more German buyers since 2020 seeking cooler residences. Your summer travel plans already adjust. Iconic hikes like the Tour du Mont Blanc reroute annually as glacier passages become unsafe. 2024's edition skips 3 traditional stages. Hotels from Chamonix to St. Moritz install air conditioning. 70% of alpine lodging lacked cooling until recent heat waves. Some ski resorts pivot radically. The Swiss village of Pontresina now markets itself as a climate change classroom, with glacier loss tours replacing downhill runs. Energy markets transmit alpine impacts to your home. French nuclear plants along the Rhone reduced output 14 times last summer when cooling water grew too warm. Shortfalls replaced by German coal power spiked EU electricity prices €45 per megawatt hour. Swiss hydro dams generate 7% less during critical summer months. That missing clean energy gets replaced by fossil fuels across the grid. Your utility bill shows these substitutions as supply adjustment charges. The ripple effect extends to everyday life. A Swiss dairy farmer, once known for award-winning cheeses, now struggles to maintain production as parched pastures yield less feed for cows. His story mirrors countless others. Small businesses and families adapting to changes they never anticipated. These personal consequences preview larger global shifts. Extreme weather connections become personal. Research links rapid alpine warming to stalled weather systems that caused 2021's deadly European floods. Events now 40% more likely according to ETH Zurich models. Your local flood risk rises even far from mountains as atmospheric patterns shift. Home insurers increasingly require elevation certificates outside traditional flood zones, an unexpected expense for many homeowners. Even recreation changes shape daily routines. Families that skied Swiss resorts for generations now book Spanish Pyrenees trips instead. Package tour prices rose 18% as demand shifts southward. Hikers buy different gear, sturdier boots for unstable trails, more water carriers for drier conditions. These small adjustments accumulate into altered traditions. No one remains untouched because no systems operate in isolation. The Rhine's low waters delayed a shipment containing bicycle parts from Germany, which stalled a Dutch assembly plant, which raised prices at your local bike shop. The connections multiply endlessly. Your life interlinks with these mountains through countless visible and invisible threads. As the Alps transform, they demonstrate processes soon affecting other critical landscapes. Worldwide, Andean water shortages, Himalayan food disruptions, Rocky Mountain ecosystem collapses. The changes arriving first in Switzerland's mountains will eventually reach your doorstep through the same interconnected systems that now bring them indirectly. Alpine ice loss both reflects and accelerates planetary transformation, a warning written in meltwater flowing downstream to your tap, your table, your bank statement. A global warning sign. The Swiss Alps function like an early warning system for Earth's climate, akin to canaries in a coal mine. What happens here today signals what will unfold elsewhere, often with greater consequences. Scientists monitor these mountains closely because changes appear earlier and more dramatically at mid-latitudes than near the poles or equator. The 2 degrees Celsius temperature rise that shrank Swiss glaciers by 60% since 1850 mirrors the same warming now affecting global systems, just on different timelines. Globally, the patterns are strikingly consistent. The Alps lost 50% of glacier ice in 150 years, while the Andes lost the same percentage in just 50 years, 3 times faster due to their tropical location. Arctic sea ice decline follows a similar trajectory, with summer ice cover reduced by 40% since 1980. These delays reflect how climate impacts propagate through Earth systems at varying speeds, with the Alps often experiencing changes first. Hydrological disruptions provide a clear example of this ripple effect. The Alps now release meltwater earlier each summer, with peak flows shifting 6 weeks since 1980. This same phenomenon hits the Himalayas with larger consequences, as their 1.5 billion dependents face more extreme river fluctuations. NASA satellite data confirms that glacial-fed rivers worldwide now peak 2 to 3 weeks earlier on average than in 1990. The per river's erratic flows foreshadow similar challenges for the Indus and Ganges basins. Food systems also reveal interconnected vulnerabilities. Switzerland's shrinking alpine pastures reduced milk yields by 8%, a moderate impact compared to the 30% production drops hitting Andean quinoa farms as their glaciers disappear. The same warming that stressed Swiss vineyards is pushing South African wine regions toward unsuitability. These shifts illustrate how agricultural belts are moving poleward at roughly 25 kilometers per decade. Infrastructure impacts scale globally as well. Swiss engineers spend €150 million annually stabilizing railways as permafrost thaws, while Alaska faces $5 billion in transportation repairs for the same reason. Italian cities ration Rhone-sourced water during shortages, just as Mexico City now does with its shrinking glacial watersheds. The physics remain identical. Ice melts, ground destabilizes, and water supplies fluctuate. Economic ripples follow similar mechanisms. A single Swiss ski resort's snowmaking costs increased 30% last decade, while Japan's ski industry now spends 50% more on artificial snow. Lyon's higher water treatment costs mirror Johannesburg's struggles with sediment from melting Drakensberg glaciers. These parallel responses highlight how climate change acts as a universal economic tax, paid differently but everywhere. Biodiversity shifts further under the global parallels. Alpine species have moved uphill 11 meters annually since 1990, while the Rockies see a similar climb of 15 meters per year. Butterflies disappearing from Swiss meadows reappear in Scandinavia, their ranges shifting poleward at 6 kilometers yearly. These movements demonstrate climate's role as a great redistributor of life. Even cultural losses echo internationally. Swiss villages hold funerals for glaciers, just as Iceland did for Okjekul in 2019. From Bolivia to Bhutan, landscapes central to identities are disappearing, turning localized mourning into a shared global experience of grief over environmental loss. Feedback loops amplify these changes. The Alps' darker exposed rock absorbs more heat, just as Greenland's ice sheet reflectivity has dropped 15% since 2000. Switzerland's thawing permafrost releases methane, while Siberian permafrost emits 20 times more. These reinforcing mechanisms operate identically, just at different scales worldwide. The timing of impacts reveals deeper truths. For every 1 degree Celsius of warming, alpine ecosystems shift noticeably within 15 years, temperate zones respond within 30 years, and tropical systems manifest changes after 50 years. This staggered response explains why Switzerland experiences today what Mumbai or Miami will face tomorrow. The Alps' transformation previews the compressed timelines and intensified disruptions awaiting other regions. Ultimately, the Alps don't just reflect global change, they actively contribute to it. Melting glaciers raise sea levels, exposed rock alters regional albedo, and economic adaptations reconfigure supply chains. What began as local environmental change now affects planetary systems through countless feedback loops. The Alps' fate intertwines with Earth's future, making their loss a global concern. The Swiss Alps reveal the stark reality of climate change and the urgency for action. While 40% of glacier loss is now inevitable, the extent of future loss hinges on today's choices. Cities are adapting water systems, and farmers are planting drought-resistant crops, proof that solutions exist. Each degree of avoided warming preserves critical ice reserves. The Alps stand as a vivid metaphor, a delicate balance between irreversible loss and the hope of preservation. Their disappearing ice and shifting ecosystems remind us that the future isn't predetermined. It's shaped by the actions we take now.